Okay, so this is 13.5 continued. These are examples where we are going to be factoring out a GCF. So remember, your goal is to create a product, and product is multiplication, okay? So we're going to have something, which we're going to call our GCF, times a remaining polynomial, okay? And what often happens is that students often just take out the GCF and think that that's their answer. So ideally what you want to think of is you want to think of the largest number that divides into 6y to the fourth and 2y to the third. And so what I usually do, when I'm teaching this in the beginning, I will take 6y to the fourth and I will factor it. That's 2 times 3 times y times y times y times y. And then I would write the next factor, 2y cubed, and that's 2 times y times y times y. And so what they have in common, I'm going to highlight. They both have a 2. They both have 3 y's. So my GCF is 2y cubed. And that goes out in the blank. And then I have to divide each one of those terms by 2y cubed. And so if you look, when I divide the first one by 2y cubed, what's left is 3y. And when I divide 2y cubed by 2y cubed, I'm left with 1. Now the nice thing is that we can always check this, okay? And when you check it, you will distribute and you will get 6y to the fourth plus 2y cubed, which is what you originally started with, okay? Now, going to the next one, I'm looking for a common number and or variable that divides into all 3 of these terms. Well, it looks like the only thing that they have in common is a 7. And so I will have, when I take 7x and divide it by 7, I'm left with x. When I take 21y and divide it by 7, I'm left with 3y. And when I take negative 7 and divide it by 7, I'm left with negative 1. And again, we can check it, and we will get originally what we started with. Now, the rule of thumb here is if your leading coefficient is negative, factor out the negative sign. So see, my leading coefficient right here is negative. So I'm going to look, what is the greatest number that goes into 12, 16, and 8, and that's going to be 4, but I'm going to make it negative since that first term is negative. And then the first one has x cubed, the second one has x squared, and the last one has x. So they only have one x in common. So when I take negative 12x cubed and divide it by negative 4x, I am left with positive 3x squared. When I take 16x squared and I divide it by negative 4x, I'm left with negative 4x. And when I take negative 8x divided by negative 4x, I'm left with positive 2. So watch that, because in Hawks, they will expect you to take out the negative sign with the factor if the leading coefficient is negative. So let's go down to this one right here, because this one is very similar. This one has a leading coefficient of negative. And so when I look at that, I am going to pull out a negative 5 because they all have a 5. And I'm going to pull out m to the third. And so now when I write my remaining polynomial, negative 5m to the 6th divided by negative 5m to the third is positive m to the third. And it's a 1, but we don't write the 1 in front of the variable. Positive 10 divided by negative 5 is negative 2. m to the 5th divided by m to the 3rd is m to the 2nd. And then negative 5m cubed divided by negative 5m cubed is positive 1. One thing to kind of check on this is that however many terms you have in your original problem is how many terms you should have in your parentheses, okay? So a lot of times students will forget that one, and that's one way to kind of check those answers, okay? All right, let's go to the one above it. And now I'm looking for the greatest number that divides into 6, negative 9, and 12, and that is going to be a 3. I'm looking at the variables that they all have in common, and they only have one x. So 6x cubed divided by 3x is 2x squared. Negative 9x cubed, negative 9x squared divided by 3x is negative 3x. And 12x divided by 3x is positive 4. Okay? Now, the next one looks a little bit different, and the thing is that our GCF in this case happens to be a group in parentheses. They both have that term in common. So just like before, I'm going to write my GCF one time, and I'm going to divide each group by x squared plus 3. And so what happens when I divide y times x squared plus 3, I'm left with y. And when I divide negative 3, parentheses x squared plus 3, divided by x squared plus 3, I'm left with negative 3. So again, your product must be a multiplication problem where there is no sign in between. And this one actually leads us into the next examples on grouping. So that finishes out factoring of the GCF.